Okay, there's first thing, if it's possible, find the x and y intercept. X-intercept is when y is equal to 0, right? So you get this, 1 over 1 plus e to the power minus x equals 0. And there is no way, as you can see, that this will equal to 0. So no, none, right? What about y-intercept? When x equals 0, right? You get y is equal to half. So 0 and half is y-intercept. You gotta check for asymptotes. There's no vertical asymptotes, but there's definitely a horizontal asymptote. When x approaches infinity, y is approaching 1 over 1 plus 0, so 1. Already following? I can feel that you're not focused.
Y-intercept, so...
Yeah. Y-intercept is when x equals 0, right?
So how do you get half?
1... oh, sorry. It's 1. 1 plus 0, right? Yeah, so it's 1. Thank you. Good. Okay. Let's do the first derivative. So you get minus that squared. So you get e to the power minus x over 1 plus e to the power minus x squared. Right? How do you know if this is approaching 0, you're saying, right? As x approaches infinity, right? This is 1 over e to the power of x.
Wait, so that's the horizontal asymptote?
Yeah, horizontal asymptote. When x approaches infinity and y is approaching that number, that's a horizontal asymptote.
And y is approaching 1?
Yeah.
So the horizontal asymptote is at 1?
Y is equal to 1. Now this is actually this. Now can this ever equal to 0? This expression here? You know that any exponent can never be negative, right? You guys should be aware of that.
What?
Any exponent expression can never be 0 because it has asymptote at y equals 0. So this actually can never equal to 0. That means there's no critical point. Anyway, this is a second derivative. We can reduce a little bit. Okay, now here's the second derivative. The first derivative, right? There's no critical point. Here, though, there is some critical points. We can turn this into 0 by setting x equal to 0 here. So there's a point of inflection at x equals 0, which is 0, 1. See this y-intercept? It's a point of inflection. So I make my table like this. I don't know how you guys make it. So the only critical point value we have is 0. I know that this is always positive, right? Because this thing is always positive. It can never turn negative, none of the components. This one here, though, is 0 here. What sign will it be when it's before, when x value is before 0?
E to the power of negative.
Alright, sorry, let's change it back to half. You confused me.
Yeah, you confused me too.
It's half, sorry, it's half. 0 and half. So, look, let's plug in like negative 1 in here. What do we get? It's negative. When you put 2 in here, what do we get?
This is chart 4 again?
To determine how it's curving, actually. When you put negative 1 in here, right? This is positive, but 1 minus e to the power of negative 1 is 1 minus e. So this is going to be negative. This is going to be positive here. Afterwards, it's going to be negative. So look, the only thing we know here Okay, so we know the asymptotes are really, really important in this graph. We know that the horizontal asymptote at 1, like this. And there's a point of inflection at 0.5 right here. Now, what happens as x approaches minus infinity actually? This is 1 plus 1 over e to the power of x. What happens as x approaches minus infinity? I don't know if you guys can see this. This is going to be 1 over 1 plus infinity basically. So you're going to get 0. So this, if you go to the right, this is the asymptote. If you go to the left, the x-axis is the asymptote. Curvature is curving up. So let me rescale this graph here to make it look a bit more obvious. Here's 1, here's half. This is the asymptote going right. This is the asymptote going to the left. Graph's going to look like this.
There's two horizontal.
Yeah, well, there's a horizontal asymptote as x approaches infinity. To the positive infinity is 1.
How come we couldn't find that though?
To the negative infinity is 0.
And you found that.
So let me reiterate how I found my asymptotes. As x approaches infinity here, right? This is 1 over 1 plus. That right there means 1 over e to the power of x, right? You can see that this is going to be the same thing as 1 over 1 plus 1 over infinity, right? Which is what? 1, right? But this is the horizontal asymptote when it goes to the right. As x approaches negative infinity, look. Same thing, we just get this though, look. If you put negative infinity there, that's the same thing as like 1 e to the power of x, same thing, e to the power of negative x. If x is approaching a really negative number, right? This is the same thing as e to the power of positive infinity. So this is 1 over 1 plus infinity, which is infinity. So 0. When it's going to the left, the horizontal asymptote is 0.
So whenever we do this, we should find it approaching infinity and negative.
Yeah. Asymptote is really important when it has the function is based on e. So to the left, and the graph is from the first derivative, the graph was always increasing, right? So this makes sense.